Cool. Morning, everyone. Thank you for joining me for this early session, early-ish session. I know there was a session even earlier. Kind of sucks having to wake up early in the morning after a fun Halloween party last night. Hopefully, everyone enjoyed that. Um, but yeah, I'm going to be presenting on a few things that I think are useful, that I think are hopefully kind of fun too, and things in core that are just, maybe something we've not done a lot of education about as Configura before, either because it was just sort of developed because, I needed something or someone else needed something and you just put it in core and then, sometimes you discover these things on your own and you're like, oh my gosh, that's so cool. But hopefully you'll learn a couple new things and maybe you can use them in your extensions, or maybe it'll inspire you to develop your own sort of tools in your own extensions. Hopefully you take away something from it. So just having a couple more trickle in here. I should introduce myself, of course, before we get started. I do have a slide at the end of the presentation that has, some contact information and stuff. But I'm Nathan. I'm a developer in the product organization at Configura here in the Grand Rapids office. I started about 3.5 years ago now at Configura, and I've had an opportunity to work on a lot of cool projects over the last few years. Anyone is familiar with prop schemes? I was on the project that revamped that and did the new dialogue for that. I was on kind of the first project team for the material handling abstract. So, yeah, I've had the opportunity to work on a few different cool things. Yeah, so just to kind of give you guys a sense of what we're going to be going over today, it's kind of a mishmash of a few different things, not super related to each other, but all kind of interesting, all kind of fun, hopefully. The first thing I'm going to be talking about is a Windows class called Pane Container. This is going to be a way to create a modular UI, more dynamic UI, UI that actually resizes pretty well. So if you're, making dialogues in your extensions, this is certainly a tool you can use. There are others, of course, and I can talk about sort of the differences between this and some of the things that maybe you've used in the past. Next, I'm going to be talking about a tool called Quick Inspect. A lot of you hopefully have heard of, seen the inspector before, when you alt-click on an object in CET and you get kind of a tree view with a bunch of information about the class. This is related to that tool. It's sort of a shortcut into it without having to inspect a particular object, but you can just kind of arbitrarily inspect any expression that you want just directly in CET. So I'll show you how that works. And then going to be showing you a debug tool called Debug Stack. That it's sort of like it's somewhere in between probes. If anyone was in the performance presentation yesterday, it's somewhat similar to probes. It also can behave a little bit like a stack trace, gives you kind of a tree structure similar to how probes do. So I'll be going over how that works. All right, so starting off with Pane Container. This is a generic container available in the CMWin package. It was developed for use with the prop scheme dialog originally. So if you've seen that dialog and you've seen how it kind of has the distinct sections in it, let me see if I can kind of point that out. So it kind of has these different sections here that are split down the middle. You have this like resizable preview area. So this is using a pane container, and the scheme painter here as well with these sort of distinct sections is also using the pane container control. Subclass is subwindow. So you can stick it in a dialog as the whole thing, just stretch it out to fit the whole dialog. You can have it just be a small portion of a dialog. You can use it a lot of different ways. The way it's sort of structured, it uses a tree structure to split up your window into multiple panes. So you start off with a big sub window, that's your entire pane container, and then you split it into either a left portion and a right portion, or a top portion and a bottom portion. Those portions can relate size-wise to each other kind of however you want. So they can have a fixed width left side and a resizable right side, or they can have a left and a right side that when you resize, they both dynamically resize to fill the space. So there's a few different ways that you can configure this. And something that this optionally gives you is if you want to create a dialog that the user can dynamically resize. So an example of that here is, again, this preview area in schemes. You can actually drag that up and down to make your preview area bigger and smaller, and that's supported natively in pane container. So I'm just going to go over a few of the properties that are associated with a pane tree node. Those are the nodes of the tree structure for the window. So we have a vertical property, which is a bool that just determines whether the split that happens is between a top window and a bottom window, or a left window and a right window. The split T is a split type. So I kind of mentioned there's two ways you can split. There's an absolute split, meaning there's a well-defined, pixels, like this window is this many pixels, and then the other one that splits off of it can resize dynamically. Or there's relative, meaning you define, say, this window takes up 40% of the width, this window takes up 60% of the width, and you can put in any kind of double value you want, and then as you stretch it out, both will dynamically fill that space. The split itself is that ratio I was talking about. Behaves a little bit differently depending on your split type. So if you have an absolute split type, it's going to want a number of pixels. And if it has a relative split type, then it's going to want just a ratio, somewhere between 0 and 1. A few more here, and then I'm going to actually get into showing you one of these and showing you the code for it. There's this fixed property. So again, this is with two windows, either a left and a right, or a top and a bottom. This determines whether this is resizable by the user. So if you set fixed to true, then there will be a drag divider in between the two windows, and the user can actually click on that and pull it left or pull it right or up and down, depending on how they're oriented, and actually dynamically resize their own UI. This could be useful if you have potentially, say, a list of things on the left side that can sometimes have longer names, and the user might want to be able to pull that over so that they can see the entire width of their texts. There's a few different applications for that. The preview area in schemes, I think, is another good example where sometimes you want to kind of zoom in a little more and see what you actually applied with your scheme a little bit bigger. If you set it to false, then it will still resize as the user resizes the entire dialog, but you can't resize that individual section. The divider thickness, this one's pretty straightforward. It just determines how many pixels are in between the two windows. There's a min split and a max split that sort of sets a bounds for, as you are resizing the window, if you have something set up to be 20% of the width, well, if the user makes it really tiny, that might make it so that you don't have enough room to display all of your controls. And so you can set up a minimum size for that window so that the user will not be able to force that window to be smaller than it needs to be. And then there's the window property itself. So the pane tree node is not a window. It's not a control or a subwindow, but it contains a reference to a subwindow. So the pane container is a window. It has an internal data structure, which is the pane tree, which is not windows, but then those refer the windows. And all of the windows, despite sort of the nested nature of the tree, every subwindow is actually a direct child of the parent window. So, all right, this is a part where I was going to show an example, but I will be happy to take some questions if anyone has them.
Quick question. You said that the panes are split always into twos.
Yes.
Can you not have any more than that? Like children of one?
So you can...
If I wanted a window that just had 3 columns instead of 2
So
sections.
the way that you would achieve that, again, it's a tree structure. So you can have nodes nested within nodes, nested within nodes. So if you wanted to have say you wanted to have 3 columns that were all equal in width, the way that I would do that is setting up the left one to take up 33% and the right one to take up 66%, and then that right one itself would have a split in it where it would be a 50-50 split between those two. And there's a couple different ways you could do that, but you can sort of achieve any setup you like. It just has to be structured as a binary tree, essentially. Oh, yeah.
You said something about all the child nodes still are just parented to the one window.
Yes.
So there's no relative controls. If I change a parent node, it's not. Does it have the capability to change a child node?
So if I understand your question correctly, as you sort of all of the logic for sizing all of the windows all the way down the tree structure is handled by the top end, the pane container. And so if you resize a node that's not a leaf node and it has children, or you move it around somehow, then those children will sort of know to rearrange themselves to fit what you did to the parent.
Is it intelligent enough where if you said, okay, so you gave the example, I would want these things 33% and then 66%, you divide that in two. If you gave it percentages that add up to more than 100%, what is it going to do?
It's a good question. I'm not sure that anyone has actually done that. I would say it's not an intended use case, obviously.
Because if you just messed it up, like I wasn't thinking very well, like I hadn't had coffee yet that morning, and then you did that.
Right. What I think
know.
you would see, if I'm just guessing, it's been a while since I've actually tried sort of edge cases like that, but I think what you might see is the two children might potentially overlap if it adds up to more than 100%. Either that or one of your children nodes is going to be like cut off. I think you would see like a visual indication, and hopefully you would be able to go back and look at how you set it up and realize, oh yeah, those two numbers don't add up to 100%. But yes.
There's a question in chat. Is orientation of the divider static or can it be changed during runtime?
Ooh, it's an interesting question. You can get into, at runtime, you can get into changing the structure of the tree, and I can show you in my example some examples of how you would do that, but there's a couple of functions on there. One, to split a node, so you can take an existing node and at runtime, say the user clicks a button and that means an extra column should pop out, then you can dynamically say, I want this thing that was one column to split into 2 columns, and then you can also remove a column or a node the same way. And I can show that in the example, which I think I'm going to get into. So let me switch over here. That's not that important right now. This is. So yeah, I wish you could see this a little bit better. It might be a little fuzzy in the back, but I tried to boost up the text size a little bit, so hopefully you can sort of make out what's happening, and I'll describe it here as well. So this first thing you're looking at in the left buffer is the pane tree node. So you can see it extends prop obj, so it is not a window. It's just its own data structure. It has these properties I was mentioning and a few others. Like I said, it can have child nodes. That's what this first and second node is. It has a reference to its window. The divider is its own window as well. It's either just going to be an empty sub window if it's fixed, or it's going to be a drag divider if not. There's a few other things in here. Here's all these properties laid out here, as well as properties. It extends prop obj. And the reason that is set up that way is so you can construct these with like arguments this way. Of course, you can also just set these things explicitly using these getters and setters if you would like. Just depends on how you prefer to work with it. Let me get down to the pane container itself. This is the one that extends sub window. It has a root pane tree node. So the pane tree node is the tree structure, so it's a root node, and then it can contain two pane tree nodes as subnodes, and then those can have subnodes, etc., etc. So you basically start this thing by creating a root, and then it builds itself. This is the build code, which I'm not going to even attempt to explain all the minutia of this thing because it is a beast of a function. As I just keep scrolling through it, you can get a sense of that the logic is a little bit complicated for aligning all of those nodes, but it is pretty smart. So again, as the user resizes things, it'll shift everything around appropriately. Here are some of these functions I was talking about. So at runtime, you can take an existing pane container and you can split it. There's a few overloads of this. So you can reference a node and say that it has a new sibling and give it some arguments for how it should split. You can reference the sub window instead of the node, and again give it a new sibling node. And then there's the same thing where the sibling is a sub window. So these two overloads here. And then there's these couple of functions to kill a node. That's the opposite of the split. So if you want to take what was two nodes and turn it into a single node, then you would call this kill function on one of the children nodes, and then the other sibling will kind of become the parent and fill the entire space. In terms of how you'd actually use this, I have this example that I've made on the right side here. This is my pane container example. This one's a dialog, but it contains a pane container inside of it. I have a couple of different build functions that I wrote here, and the reason I did that is I wanted to show you a couple different ways to work with it. So this build one is sort of the minimal code example. So this is like the least lines of code you can write to get this thing. So it creates the pane container sub window. It makes it so it fills the whole space. It creates the root on it with a window in that root, and then it calls split, 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 build. So it's very much the way that you think of that is building it from the inside out, sort of. So the root node ended up actually being one of the leaf nodes, and then as I split it, then that root node became a child, and it got a sibling, and then there was a parent, and then I split that again, and it became like a grandchild. And so you can kind of build up the tree that way, and you can see it's very few lines of code to build something up. But I think that it isn't super indicative of what the actual structure is. I think it's a little hard to read. So if you want to be a little more verbose about it, I have this build 2 example here that sort of more clearly lays out, here's a root node. I set the root to be that root node. I set some properties on it, and then nested within here, I have like these two children. And then nested within this one, I have these two children. So I've basically used the indentation and sort of more explicitly defining it so that the structure of the code reflects the structure of your window. So I guess I should show you what this actually looks like. So if I'm going to run this and switch over here, this guy is my very simple pane container, sort of loosely modeled off of Visual Studio, actually, because I just randomly took inspiration from that. So you have like your solution list of different files and stuff over here. You have an output buffer on the bottom, and then the way I like to use Visual Studio a lot is to have like a left and a right sort of file. So I have two sets of tabs, and I can switch between them. So you can see as I resize this, it will resize to fill the space. These two, the left and the right, are set up to always be equal and equivalent sort of width. So as I resize this, you see that they fill up to have the same ratio. As I make it small, they do the same thing. The solution thing on the right here, that is a fixed width, and it's an absolute width, and then the output on the bottom is also fixed. I can also drag this, so this is an example of a not fixed split. So I can drag this over there, I can drag that over there depending on what is more important to me in the moment. So if I drag it way over here, so the left is tiny, and then I resize it, it's going to continue to respect the fact that the left should be really thin and the right should take up more space. Yeah.
So if you resized, so pretend left was a list of files or something. If you resized it, but you wanted it to stay static at that new size, could you do that? Could you set it so that when you resize it, it interprets the new size as whatever one of them would take that as like a fixed width, that new, like, this is what I want, or does it when you
Sure.
resize, does it always do percentages?
No. So this split here between the left and the right is set up to be a relative split. So that's why I can, drag it here, and then as I make it smaller, they both get smaller, and as I make it bigger, they both get bigger. I believe I set up one of these, the solution. Here we go. So this one's also resizable, but it's resizable at a fixed width. So if I resize this to be bigger, it now takes up this much room, and as I resize it, it's always going to take up that amount of width. So it depends on how you set up the splits. Again, if you want a relative split, like I have between the left and the right, you use the pane split type dot relative. And if you want it to be absolute, where it's a fixed amount of pixels, then you would use the absolute split type. Any other questions? I have one over here. The question was what package is it in? And the pane container is in CMWin. So I think everybody should have access to that one, hopefully. I think it's exported with core. So yeah, so this should be available for anyone to try out if you're interested. I have a question in the back here.
Yes, I was just wondering, is there any way we can access this test dialog to see how you guys built it out?
That is such a great question, and something that I was supposed to do before this presentation and did not do. There is a repository somewhere of like CETX code examples that I will be, shortly after this, I will make sure that these are pushed there. And do you know, is Paul in charge of that repository?
I don't know who's in charge of it, but I also know that there is an example in the class that defines this at the very bottom. It's not exactly like this, but it does have like examples with pretty colors.
That is true, yes. So there is a different example in the actual code file for pane container. So if you want sort of something that's not going to look exactly like this, but something that's going to demonstrate some of the capabilities, you can go there. All right, if there's no more questions, let's get back to some more fun core features. All right. Yes.
If you kill a sibling, so if you had two siblings, one you set them to like 50%, and you kill a sibling, the one sibling left will resize to 100% then, right?
Yes.
What if you put a sibling back in? Does it keep track of it? Yeah, I used to be 50%, now I should go back to that?
You have to explicitly define the split every time that you redo the split.
Okay, thank you.
All right, let's move on to something else. So I'm going to be talking about the Quick Inspect tool next. This is not really it is a useful tool for development for sure, but it's not really a code tool. So it's something you're actually going to be using in CET. This provides an easy way to inspect globals without leaving CET. I say globals loosely because you certainly can use it to inspect globals, but you can also use it to inspect any expression that you have access to globally. So you can drill into, main space dot snappers dot, first dot whatever, or you can do, you can actually wrap a more complicated expression where you iterate over a list and inspect the first thing that matches some criteria. So it's pretty dynamic the way you can work with it. While you are using CET in develop mode, if you have any CET view in focus, you can just hit Alt-I. I suppose it's possible that even you've accidentally run into this, but it's a little bit hidden. But hopefully you're used to the Alt-I muscle memory from Emacs, so this just works the same way in CET. One exception here, and this is kind of for a legacy reason. If anyone was here a few years ago when the new inspector was presented by Connor Dudas, then the animation inspection was something that was introduced then. So if you're currently animating and you hit Alt-I, it'll just go straight to inspecting that animation that's running. But if you're in any other situation in CET, you can use the Quick Inspect tool. Any expression that doesn't access package or private variables or functions is valid, so same way that you would write an expression anywhere else in your extension code. You can't obviously use private stuff unless you're really sneaky and know about some of the CM runtime stuff. Yeah, you can access basically anything that should be publicly available in your expression. So here on the screen is the Quick Inspect tool. So when you hit Alt-I, this window is going to pop up. It's going to display on top of your active view, kind of right in the center. So it may be your 2D view or your 3D view or your paper view, just depending on what you're working in CET. Has these two fields, a use field. This is where you're going to list any packages that you need in order for your expression to run. And then the bottom field here is where you're going to actually type your expression, and you can use the tab key or click to get between these fields. Again, here, adding relevant expressions. There is an X button here if you want to close it, but you can also just hit escape to close the window. And then once you've typed out your expression and you are ready to run it, you just hit the enter key. When you have this, actually it may even work when you have either field in focus and you hit the enter key. And then it's going to pop up an inspector window that's inspecting whatever expression you just wrote. So this one's one that is much easier, I think, just to show how it works than to have a bunch of slides that talk about it. But if anyone has questions on it before I show it, then I can take a question.
Does it work only in dev mode?
It does only work in dev mode. it'd be a little bit weird if a user accidentally hits Alt-I in their CET and suddenly they can arbitrarily execute code. So we maybe don't want to do that. I can imagine where it could be potentially useful to use in release mode, but I think the inspector itself is also only available in dev mode, so it kind of fits with that. I could see in the future if it was a really important, feature for somebody that you could have like a special flag on in release mode or something that would let it work, but I don't think that that's anything that's in the pipeline right now. All right, back to this guy. So here I've just sort of pre-set up my CET with just some random objects here. It's just not important what they are. They are test cabs, and they're just kind of laid out here. So something that one might want to do if they're in a space that's probably more complicated than mine is here. Maybe you have a lot of overlapping snappers or something like that, and you want to just get a very quick, easy sense of like what is in my space. Well, if I'm already in here and I'm looking at a drawing, then I can just hit Alt-I here. And you're going to see in the middle there that window pops up. It defaults to having these 4 packages in the U's. So CMWin, CMCore, CMIO, CMGeometry. Covers a lot of stuff, but obviously it's not going to cover anything in your extensions. So if you wanted to add something, another package, then you would just hit the tab key, and now you're up there, and you could add, I'm going to add, cm.core 3D, because maybe I want to inspect some graphics or something like that. Go back here, I'm going to type my expression. We'll start out simple. I just want to know what snappers are in my space. So I'm just going to type main space dot snappers, hit enter, and a little inspect window is going to pop up. So this, again, this is the one that we've presented on in the past. If you have questions about the inspector itself, I'm happy to talk to people about how it works. But it's basically just a tree view that sort of gives you a nested view of whatever you want to inspect. So in this case, it's a snapper set, has 4 things in it, my floor snapper and my 3 test cabs. I, of course, could have told you that without inspecting it. But again, if you have a very complicated drawing, then maybe this would actually be useful to see how many snappers you have in space, or something like that. I can, of course, open these up individually. So if I want to see what properties I have set on my test cab, for example, I can open that one up, and I get all of my normal inspector things. Any prop defs are listed here in this table, and then all of my fields are listed here in a tree view style. And I can continue to open this up. So if I want to go further and inspect this like connector, then I can go here, and it has properties, and et cetera, et cetera. So maybe a more complicated example, I was talking about, being able to arbitrarily say, I want this expression, right? So I can open this up again, and I can wrap basically any code I want in brackets. As long as it results in something, then it will be valid. So I can just start this immediately with saying result true, so that it will actually be a valid thing that I can inspect. And then here I could put in really anything I wanted. So I could like iterate over my snappers, for example. I could say for z in main space dot snappers z dot set pose. Where do we want to set it to? 0, 0, 0. Actually, I don't even remember what the signature for that is, if it takes 3 ints or if it takes a point. So I guess we're going to find out if this runs in real time. But yeah, once I have that expression here, I can just make sure everything's spaced out appropriately as well. But yeah, I write this expression. It results in something, which means it's valid to inspect. And then I run it. It didn't inspect anything, which means that I did have the wrong signature on there. So if your expression, it doesn't compile or it's not valid, then you'll see a null type here, and I think you also get a message in Emacs here about why it failed. There we go. So here it's saying that set pos is not valid. Let me double check what that actually is. That seems like a basic one that I should know. A point. So just put parentheses around it. Okay. That's kind of what I thought it would be if it wasn't the thing that I put. So closing that, Alt-I again, for Z in namespace dot snappers. We're going to Z dot set pose. Oh my god, I can't type today. This is crazy. Result true. And then let's put in actually a point here. So say 0, 0, 0. And hopefully that will compile. It does. Of course, you didn't see anything happen here because set pos doesn't do an invalidate. But if I now go here and I hit F5, then you'll see these are all just kind of a mess. They're into each other. Now, that example, of course, is very arbitrary. You might not actually want to do something like that, but it could be useful to execute some sort of code here to move something or to set a property on something without having to do it through the interface or to do it in an automated way. See a couple questions back here.
First question is the package usage, is that recursive? So is it, if I, say custom extension, will it go through all sublayers or no?
It will not. It works the same way as using statements do in a normal CM buffer, so it's on the package level. So if you have a sub package, using the parent package does not use the sub package.
Okay, and then second question is actually more of a comment. Just curious, but it's probably not there. If there's like a history saved on your code queries and stuff that you enter in.
Let's see.
If you if you do a quick search and you're like, oh, I want to run that same quick search again.
So if you open up the inspector, there is this recent section here that has the things that I've recently inspected. It's a good question if it actually works, because this tool has not been touched in a while. So it looks like that's a little bit broken. So you do at least have you can see them displayed here, and the intention is that you'd be able to click them and rerun it, but I think it doesn't work well for these like ones that are arbitrary code execution. Anything else I've inspected just by alt-clicking on something, I can like go in here and double-click on it and see it in this history though.
Is there any way to set like default preferences on just the using field so you don't have to keep entering in numerous extensions over and over again for similar queries?
There's not right now, but that would be an excellent thing to add. I totally agree with you. In fact, I find that annoying. So I think, yes, that's something if we get the chance to add that as a quick little thing in core, I think that would be a good idea. All right. So have one more topic to talk about. So let's switch back there. Debug stack is the last one I'm going to go over. This one is a syntax similar to probes, but I can show you what the difference is there. It sort of shows you a stack, but in a sort of a tree structure with counts on calls and stuff like that. It's found in cm.core.debug, so that's where we're going to access this. It includes only functions that you have added the syntax to. So like probes, you have to, for every function that you want to have in your debug stack, you have to just wrap it in that syntax. It forms a tree structure, outputs an Emacs, shows the call counts. This could be useful for performance hunting. It doesn't give you all of the same information as probes does, like about amount of time that each run takes and stuff like that. but you can kind of more quickly, I think, see some things like, oh, this function's getting called 100 million times. Like that's maybe kind of a problem. So this is what the actual syntax looks like. It's pretty simple. You just say debug stack, and then you put in this conditional expression. Basically, just on the one that you actually want to have print out the result. So that's typically going to be the most parent debug stack. You're going to say true in there, and then all of the rest of them don't even need a condition at all. So it's just debug stack, brace, some code, end brace. So this is what the output looks like. Just a bit for understanding it. The root represents the outermost function where you added the syntax, and then the entries below are indented appropriately for like who they were called by, and you see the numbers in brackets are the number of calls. The function can also appear in the tree multiple times if it was called from multiple different places, so you may have to do a little bit of math to figure out if its constructor was called here and there, so it has like 3 plus 1 calls, so it's 4. And then, yeah, the number at the end represents the number of calls from that particular parent, not the total calls in everything. So like I said, you may have to sum some things. Yeah, so this one, too, I can show an example of. There we go. So I have that here of sort of an arbitrary place where I have set this up. So this is just my kind of sort of contrived, I have a couple of classes, one that extends the other, has an extendable method here that's overridden here. It has constructors that call down to super, a couple different constructors. And you can see what I've done here is basically just wrap each thing in debug stack. So the benefit here, I think, versus probes is that you don't have to explicitly put in a string of like, I want to call this thing. Like it will just know what function it's in and it will name it in the output appropriately. And then I have this debug stack true around this function that calls all of these things. So the true again means that it's actually going to output in Emacs when I do it. So let me get this buffer here sort of ready to show you that. Not that one. There we go. So now if I run this, so I have a couple different outputs here. These ones are just all of the PLNs that I put in these functions. So that just shows you kind of what the tracing would look like if you were only using PLNs. It's flat. It's hard to kind of understand what's happening. And then there's this tree structure here. So you can see the top call was this function called C. It called the constructor for the A class, the constructor for the A class that takes an int, constructor for the B class that takes an int, and then these couple of functions here. And then you can see all of the subcalls that I put the syntax on. And each of these are clickable. So in this tree, I can click on the A constructor and it'll take me up there. I can click on this B constructor, it will take me down there. So you can kind of hop around the code that way as well. It's kind of all I got for this one, but yeah, questions?
I just wanted to clarify something, because this seems pretty cool. So you just put true in the parent, like the start of the debug stack call.
Exactly.
So you could just, so if I were to put in, like, if I only want to do debug stack for like a snapper with a certain GUID,
Yes.
I could do a check in there,
Correct. This can be any expression that returns a bool.
and then every debug stack outside of that will not get added if it's not also, if that is not also the case, right?
Yeah, so right. So anything that's like a sub debug stack, so a debug stack that's in anything that this one calls will not be added.
Okay, cool.
So the outermost one, you just have to put some condition in, and then if it's true, all of its children debug stacks will get added, and if it's false, then nothing will show.
Got 1 minute.
Well, that's good, because looks like we don't have a bunch more questions. So this is me. This is my email address if you want to bug me about any of the things that I showed you today that you're trying to use and it's like, this is garbage, why does this suck? Reach out to me and I'll be like, yeah, you're probably right. Yeah, super cool. Thanks everyone for coming and listening to me talk.